All right, so now we want to talk about what the soil looks like and how that's going to have affected how this landscape was used. So here's the hole we've taken the soil out of, and as I said, we put it down layer by layer. Okay, so each increment as we're going down is deeper into the soil profile. This is perhaps the first 20, 25 centimetres and then down to 60 or so. And so you can see there's a very, very clear separation here. You've got this grey material, sandy material in the surface, and then you move to a lighter coloured clay material at depth. And so a very, very distinct change. And so when we classify this soil, when we give it a name, that nature, sandy, light textured surface, and a very distinct change to the heavy clay subsoil is one of the characteristics that we would use to say this soil is a curasol soil. Curasols aren't very fertile. Part of the problem that they have is the water dynamics. And so remember, I showed you that the water would go in very easily to the surface soil, but it would go very slowly into the subsoil. And we've made measurements of this at a site not far from here. The surface soil, we could get 200 millimetres, okay? 200 millimetres per hour would infiltrate into the surface soil. Whereas the subsoil, 2 millimetres every day. So 200 millimetres per hour into the topsoil, 2 millimetres per day into the subsoil. What's going to happen when we get a prolonged period of rain here? Water's going to soak into the surface soil, keeps raining, more water soaks in, the surface soil fills up with water, but we can only get that water into the subsoil at 2 millimetres a day. So the surface soil is going to become completely waterlogged. Water's going to move laterally through the soil towards the creek, but also water's going to run across the surface into the creek. Okay, so we don't get a lot of water into this soil when it does rain, only the surface is going to get wet. And then when we go into a period of dry weather, the plants that are growing here, and if we were trying to grow crops, the only water that they would have is the water that went into the surface soil. Not much is going to go into the subsoil, and because it's such heavy clay, it's difficult for roots of crops to go into that. So traditionally this land was never used for cropping. It was used for low-grade grazing, beef cattle, on pretty much unimproved pastures. So a very low value land use because the soil was not very fertile. Now, in a couple of minutes we'll measure the soil pH. We'll show you how we can use field test kits to do that. But jumping ahead, the soil is slightly acid, so somewhere around 5. And once again, this is a characteristic that makes this a fairly infertile soil. Now I wanted to tell you a little bit about the way that this soil then the way that this soil affects how we might use the soil in an urban landscape. Later in this field trip, or in another part of this field trip, you'll be visiting some upland areas where we were particularly concerned to protect the habitat for koalas. So we ensured that there were large land areas with a defined area as the envelope that you could build a house on, and the rest of the land was to be maintained with its vegetation for the koalas. But another environmentally friendly characteristic of that land use, or the housing estates there, is that they use on-site disposal of sewage. So in most residential areas, when you flush the toilet, the water goes out, down a pipe, down other pipes, and eventually ends up at a water treatment plant, at a sewage treatment plant, often kilometres from where your house is and serving thousands or tens of thousands of houses. But in the area where they're trying to protect the koalas, you flush the toilet, it goes out into a tank on your land, the initial treatment of the sewage takes place there, and then the overflow from that tank soaks into the soil on your land. So there's a little mini sewage treatment plant for every house. And on the area that you'll look at with the koalas, the soils there are very deep, very permeable, so the water can move through them very easily. I want you to think about putting a similar on-site disposal system on this soil. Okay, so we have our tank in the ground, and then we dig some trenches. What are the trenches going to be down into? They're going to be down into that subsoil. How fast does water soak out of that subsoil? Okay, 2 millimeters a day. So, imagine, you've got a house here, you're a sociable kind of person, you decide you're going to have a big party for your mates. Guys turn up with a slab, order some pizzas, toilet gets flushed every 2 minutes, another 8 litres, another 8 litres, out into your sewage treatment system. Water flowing out of the tank into these trenches that you've dug for the water to soak away. Every 2 minutes, another 8 litres when somebody goes to the toilet. What's going to happen? Well, the trenches are going to fill up with water, because remember, the water's only getting out of them at 2 millimetres per day, soaking down. So the trench fills up with water, the trench overflows, you've got untreated sewage bubbling up in your backyard, the guys have decided to play a game of soccer out there, there's a bit of splash. It's a pretty ugly scene, isn't it? Now, don't misinterpret what I'm saying. I'm certainly not saying that on-site disposal is a bad idea. It's actually a really good idea, because it puts water into the landscape, and water will soak through, nourish the trees, maybe even some of it will eventually get to a creek. That process of flowing through the soil, the water's cleaned up very, very rapidly, so it's high quality water. Okay, so I'm not saying on-site disposal doesn't work, it does. But what I am saying is that you need to think about the soil in the area where you are considering on-site disposal. So if you're a town planner thinking about a new suburban development and you're considering maybe on-site disposal would be good here, what the soil is like would be one of the things that you'd need to think about. How rapidly can water escape from the trenches? Is it a soil like this where it's really going to get out slowly and the system won't work? Or is it a soil like the area where we're protecting the koala habitat where it will work perfectly?